let's take a look at this problem. We got f of x is equal to x squared minus 9 over x plus 3. And it says to graph the function, determine the continuity. Well, we determine continuities just like before. If you set your denominator equal to 0 and solve it, we get x is equal to negative 3. This is a value that causes the denominator equal to 0, which means we can't have that. So x cannot equal negative 3. It means we have a discontinuity at x is equal to negative 3. Well, let's graph this. I'll press I guess I already have it in there. Okay, so press my y equals, press my clear to clear out whatever's in there, do a beginning parentheses, x squared minus 9, close parentheses, divided by, beginning parentheses, x plus 3. Key to graphing this is, if you have more than a single variable, single number, and top and bottom of your fraction, you have to put parentheses around it. So I put parentheses around the top, parentheses around the bottom. Now let's graph this. Okay, discontinuity at x equals negative 3. If I go to negative 3 and I come straight down to where my graph is, I don't see any discontinuity. There's no hole there, there's no gap. It looks like it's a nice straight line. It's actually not, but let's go ahead and sketch that. Let's see. Something like that. 2, 3. Okay. Yeah. Now, if I go back to my original function, if I factor the top, factor the bottom. The top is difference of two squares, and factors as x plus 3 times x minus 3. Now notice after I factor the top part, this has an x plus 3, and this has an x plus 3. They cancel. So that disappears. And we're left with x minus 3. When it disappears like that, your discontinuity disappeared. We'll talk more about that in future problems. But that means that it's a hole in your graph. It's not a gap, it's a hole. So if I come to negative 3, go straight down, what we should have right here is we should have a hole in our graph. So that would be our graph right there.